Hi everyone. In this lecture, I would like to explain about monographs of sodium bicarbonate and milk of magnesia. Coming to the contents of this lecture, monographs of sodium bicarbonate and monograph of magnesium hydroxide mixture. So here you can see that sodium bicarbonate and magnesium hydroxide mixture both are used as antacids. Sodium bicarbonate and magnesium hydroxide mixture both are used as antacids, and these are the examples of antacids. And sodium bicarbonate, it is the example of water soluble antacid, and magnesium hydroxide mixture, it is the water insoluble antacid. The difference between these two antacids, that is, one is water soluble antacid and the another one is water insoluble antacid. Sodium bicarbonate, it is the water soluble antacid. Magnesium hydroxide mixture, it is the water insoluble antacid. So let us discuss about the monograph of sodium bicarbonate. Sodium bicarbonate, it is also called as sodium hydrogen carbonate. Sodium hydrogen carbonate, and the formula of sodium bicarbonate, that is sodium NaHCO3. NaHCO3. And the synonym of the sodium bicarbonate, it is generally called as baking soda. Baking soda, that we are generally used with the name, that is baking soda. That is the synonym of sodium bicarbonate. And the molecular weight of sodium bicarbonate, that is 84 gram per mole. And it consisting of 99% to 101% weight by weight of sodium bicarbonate in its preparation or in its substance. And coming to the properties of sodium bicarbonate, it is a white crystalline powder and it has saline taste. And coming to the solubility of sodium bicarbonate, it is freely soluble in water, but it is insoluble in alcohol. Solubility, that is freely soluble in water but insoluble in alcohol. And the sodium bicarbonate, it gives effervescence when reacting with acids. So whenever the sodium bicarbonate is on reaction with acids, that leads to produce effervescence. That is due to the evolution of carbon dioxide gas. The sodium bicarbonate consisting of the carbonates are there, when it on reaction with acids, that leads to produce carbon dioxide gas, that is nothing but effervescence that is produced in that reaction. And the solution of sodium bicarbonate, it is alkaline in nature. It is alkaline in nature. Coming to the preparation of sodium bicarbonate, small scale preparation. In small scale preparation, the sodium bicarbonate, it is prepared from sodium carbonate. Sodium carbonate. So initially that sodium carbonate, that can be prepared just by reaction of sodium hydroxide with carbon dioxide. The carbon dioxide which is passed through the sodium hydroxide solution, then it gives sodium carbonate. Then that sodium carbonate which is treated with water and carbon dioxide, it gives sodium bicarbonate, which is the small scale preparation method from sodium carbonate. And coming to the industrial scale of preparation of sodium bicarbonate, in case of industrial scale of preparation, the sodium bicarbonate, that is prepared from the carbonated water. So initially the carbonated water, that is prepared by reaction of water with carbon dioxide, that leads to produce carbonated water. Then the carbonated water which is treated with ammonia, carbonated water which is treated with ammonia, that leads to produce ammonium bicarbonate. Then this ammonium bicarbonate, that is treated with brine solution. Brine solution is nothing but salt solution, that means salt in water. Brine solution means it is ranging from nearly approximately 3% to 26% of sodium chloride. That is nothing but brine solution. So ammonium bicarbonate which on treatment with brine solution, that is nothing but sodium chloride solution. Generally it ranges from 3 to 26% concentration of sodium chloride. So the reaction of ammonium bicarbonate with brine solution that leads to produce sodium bicarbonate. So ammonium bicarbonate, in which the ammonium which is replaced with the sodium of the brine solution, and it gives sodium bicarbonate as the product. So this is the industrial scale of preparation of sodium bicarbonate from carbonated water. And coming to the identification tests of sodium bicarbonate, here you can see the identification test for the sodium bicarbonate, it consisting of sodium ions and bicarbonate ions. In generally, the 5 ml of 5% weight by volume of solution in carbon dioxide free water, the sample solution, that is 5 ml in 5% weight by volume solution in free carbon dioxide free water. To that, if we can add the 0.1 ml of phenolphthalein, then it produces the pale pink color. That indicates it is the sodium bicarbonate. Further, whatever the pale pink color that is produced, it on heating, the solution which on heating, it evaluates the gas evolved, okay, produce the evaluation of gas, and the solution becomes red. The solution becomes red from pink color. So whatever the pink color solution that is initially produced, that pink color solution, further it on heating, that leads to produce red color. By the evaluation of gas. That indicates that presence of sodium bicarbonate. And the solution of sodium bicarbonate or the sample of sodium bicarbonate, it gives the following test for the sodium ions, because the sodium bicarbonate consisting of sodium is the cation and bicarbonate is the anion. So the test for sodium ions, that is the sample consisting of sodium ions, it on treatment with potassium antimonate solution. When it on treatment with potassium antimonate solution, that leads to produce white precipitate of sodium pyroantimonate. So the formation of white precipitate of sodium pyroantimonate, it indicates the presence of sodium ions in the sample. Another identification test for the same sodium ions, the sample consisting of sodium ions which on treatment with magnesium uranyl acetate solution. Magnesium uranyl acetate solution is nothing but it is the mixture of uranyl acetate and magnesium acetate and acetic acid solution. The mixture of uranyl acetate, magnesium acetate and acetic acid, that is nothing but called as magnesium uranyl acetate. So the sample consisting of sodium ions when it on treatment with magnesium uranyl acetate in presence of water, that leads to produce greenish yellow precipitate because of the formation of sodium magnesium uranyl acetate. The greenish yellow precipitate that is produced, that indicates that presence of sodium ions in the sample. Coming to the identification test for the bicarbonate ions. So the sample consisting of bicarbonate ions when it on treatment with magnesium sulfate in cold condition. So the sample consisting of bicarbonate ions when it on treatment with magnesium sulfate in cold condition, there is no reaction or there is no formation of precipitate. That indicates that bicarbonate ions which are present. And this is one of the distinguished tests from carbonates. For example, for the same reaction, if you are performing with carbonates, it undergoes reaction, it produces the precipitate in cold condition. But the bicarbonates, when it on reaction with magnesium sulfate in cold condition, no reaction and there is no formation of precipitate. That indicates that bicarbonates are present. And the bicarbonate solution when it on heating or boiling, bicarbonate solution when it on heating or boiling, that leads to evolution of carbon dioxide gas. Bicarbonate solution which on heating or boiling, that leads to produce carbon dioxide gas evolution. That indicates that presence of bicarbonate ions. And another identification test for the bicarbonates. Bicarbonates which on treatment with acetic acid, that leads to produce releasing of carbon dioxide gas, evolution of carbon dioxide. Bicarbonates which on treatment with acetic acid solution that leads to produce or evolution of carbon dioxide gas. So whatever this carbon dioxide gas that is produced in that reaction, when it is passed through the barium hydroxide solution, that leads to produce barium carbonate precipitate. Then that barium carbonate precipitate which on treatment with hydrochloric acid solution, that leads to produce barium chloride white precipitate. So the formation of these precipitates that indicates that presence of bicarbonate ions in the sample. Presence of bicarbonate ions in the sample. And coming to the test for purity of sodium bicarbonate. The sodium bicarbonate which is alkaline in nature, the alkalinity of the sample that can be determined by titrating an aqueous solution of the sample with 0.1 normal hydrochloric acid solution using indicator methyl red. It states that the sample which is alkaline in nature. And pH of the 1% solution that is not more than 8.6. The pH of the 1% sodium bicarbonate solution that is not more than 8.6. And acceptable limits of chloride ions that is not more than 200 ppm. Acceptable limits of sulfate ions not more than 150 ppm. Acceptable limits of iron not more than 20 ppm. Acceptable limits of heavy metals not more than 5 ppm. And acceptable limits of arsenic that is not more than 2 ppm. And sodium bicarbonate, it is the antacid, so that which is having neutralizing capacity. That means it has ability to neutralize the gastric acid, so that we have to test for neutralizing capacity. The neutralizing capacity indicates that it has to consume not more than 50 ml of 0.1 molar sodium hydroxide solution. And while performing this neutralizing capacity test, we have to maintain the temperature that is 37 degrees centigrade during the complete process. So for this process, we have to take 5 grams of the sample which is dissolved in 100 ml of hot water. The temperature condition that is maintained, that is 37 degrees centigrade. Then add 100 ml of 0.1 molar HCl solution which is previously heated at 37 degrees centigrade, and stir the solution and maintain the temperature at 37 degrees centigrade up to 20 minutes. Then after 20 minutes, the pH of the solution, it becomes 3 to 4.5. So whenever the pH of the solution it becomes 3 to 4.5, then add 10 ml of 0.5 molar HCl solution which is previously heated to 37 degrees centigrade, and stir the solution continuously for 1 hour and maintain the temperature 37 degrees centigrade during the process. And finally titrate it with 0.1 molar sodium hydroxide. While titrating with 0.1 molar sodium hydroxide solution, it consumes not more than 50 ml of 0.1 molar sodium hydroxide solution. It indicates that the sample, it has the neutralizing capacity. And loss on drying value of sodium bicarbonate, that is not more than 0.25% when 4 grams of sample that is dried in oven at 130 degrees centigrade for 4 hours. And the microbial contamination, that is not more than 100 microorganisms per ml. The viable aerobic count, that is not more than 100 microorganisms per ml, and the complete sample should be free from Escherichia coli, gram-negative organism. And coming to the assay of sodium bicarbonate, it is assayed by acid-base titration method. 1 gram of the sample, that is sodium bicarbonate, dissolved in 20 ml of water, and then titrate with 0.5 normal sulfuric acid solution using indicator methyl orange until faint pink color observed as endpoint. Coming to the uses of sodium bicarbonate, it is used as electrolyte replenisher for sodium ions. That means it acts as sodium replenisher, and it is also used as acid base regulator. It is also used to neutralize the gastric acid, that means acid neutralizer. It is used for the treatment of systemic acidosis. It is used as systemic alkalizer. Systemic alkalizer means which is used for the treatment of systemic acidosis. Used as antacid, used for the treatment of hyperacidity or hyperchloridria, and it is also used in the preparation of buffer solutions. The sodium bicarbonate and carbonated water or carbonic acid mixture, which is used as buffer solution, and aqueous solutions of the sodium bicarbonate, it is used as local applicant for burns and insect bites. And sodium bicarbonate, it is used as one of the constituent of effervescent mixture. So one of the constituent in the effervescent mixture, that is sodium bicarbonate. These are the uses of sodium bicarbonate, and this is about complete monograph that is related to the water soluble antacid, that is sodium bicarbonate. Coming to the monograph of water insoluble magnesium containing antacid, that is magnesium hydroxide mixture. The other names are synonyms that can be used for this magnesium hydroxide mixture, that is it is also called as magnesium hydroxide suspension, or it is also called as milk of magnesia or cream of magnesia. And molecular weight of magnesium hydroxide, that is 58.32 gram per mole. And magnesium hydroxide mixture consisting of not less than 7% and not more than 8.5% weight by weight of hydrated magnesium oxide in the form of magnesium hydroxide. The magnesium hydroxide mixture consisting of, it contains not less than 7% weight by weight and not more than 8.5% weight by weight of hydrated magnesium oxide, which is calculated as magnesium hydroxide. Coming to the properties of magnesium hydroxide mixture, it is a white uniform suspension. Water may separate on long standing because it is the suspension. So one of the important property of the suspension on long standing, separation of water as clear solution in the form of supernatant liquid. And solubility of magnesium hydroxide mixture, that is it is insoluble in water and in alcohol, but it is soluble in dilute acids and in ammonium salt solutions. Soluble in dilute acids and ammonium salt solutions. Coming to the preparation methods of magnesium hydroxide mixture, it is prepared by the reaction of magnesium sulfate with sodium hydroxide solution. Magnesium sulfate, when it on reaction with sodium hydroxide solution, that leads to produce magnesium hydroxide precipitate. And another method of preparation of magnesium hydroxide, that is magnesia, which is treated with water. Magnesia is nothing but magnesium oxide which on hydrolysis, that means treated with water, that leads to produce magnesium hydroxide. These are the preparation methods of magnesium hydroxide. And coming to the identification test for the magnesium hydroxide, a solution of 1 ml in dilute HCl. Solution of 1 ml in dilute HCl. That means the 1 ml of the magnesium hydroxide mixture in dilute HCl solution, it gives the positive results for the magnesium ions. So coming to the test for magnesium ions, the sample consisting of magnesium ions which on treatment with ammonium chloride solution. Sample consisting of magnesium ions which on treatment with ammonium chloride solution, it gives the clear solution. That means the Sample consisting of magnesium ions which are completely dissolved in that ammonium chloride solution, so that it produces the clear solution that indicates the presence of magnesium ions in the sample. And another identification test for the magnesium ions, the sample consisting of magnesium ions, it on treatment with sodium phosphate dibasic or dibasic sodium phosphate in presence of ammonium hydroxide and water. It gives white crystalline precipitate of magnesium ammonium phosphate. That indicates that presence of magnesium ions in the sample. So once again I repeat, the sample consisting of magnesium ions which on treatment with sodium phosphate dibasic, or it is also called as disodium hydrogen phosphate in presence of ammonium hydroxide and water. It gives white crystalline precipitate of magnesium ammonium phosphate. That indicates that presence of magnesium ions in the sample. Coming to the test for purity of magnesium hydroxide mixture. The magnesium hydroxide mixture which is alkaline in nature, so the alkalinity nature of the sample which is determined by titrating an aqueous solution of the sample with 0.1 normal hydrochloric acid solution using indicator methyl red. And coming to the acceptable limits of chloride ions, that is not more than 150 ppm. Acceptable limits of sulfate ions in the sample, that is not more than 200 ppm. Acceptable limits of iron not more than 20 ppm. Acceptable limits of heavy metals, that is not more than 4 ppm. Acceptable limits of arsenic not more than 1 ppm. And coming to the microbial contamination, the viable aerobic count, that is not more than 100 microorganisms per ml, and that should be free from Escherichia coli. So the magnesium hydroxide mixture should consisting of not more than 100 microorganisms per ml, and it should be free from Escherichia coli, which is the gram negative organism. And coming to the neutralizing capacity, so the magnesium hydroxide mixture which is antacid, which is having ability to neutralize the gastric acid, hence we have to test for neutralizing capacity. The neutralizing capacity procedure for the magnesium hydroxide mixture and the sodium bicarbonate, that is same. The sample which is dissolved in 100 ml of hot water, that is 37 degrees centigrade hot water, and we have to maintain the temperature 37 degrees centigrade during the complete process. Then add 100 ml of 0.1 molar HCl solution which is previously heated at 37 degrees centigrade, and stir the solution and maintain the temperature at 37 degrees centigrade for about 20 minutes. And after 20 minutes, the pH of the solution, it becomes 3 to 4.5. Then add 10 ml of 0.5 molar HCl solution which is previously heated at 37 degrees centigrade, and stir continuously for 1 hour and maintain the temperature of 37 degrees centigrade during the process. And finally titrate with 0.1 molar sodium hydroxide solution. And it consumes not more than 50 ml of 0.1 molar sodium hydroxide solution. It states that which is having neutralizing capacity. If it exceeds 50 ml consuming of sodium hydroxide solution, which is not having that much of neutralizing capacity. And coming to the assay procedure of magnesium hydroxide mixture, it is assayed by acid-base titration method. Take 5 ml of magnesium hydroxide mixture and add 25 ml of 1 normal sulfuric acid solution and titrate with 1 normal sodium hydroxide solution using indicator methyl red until yellow color obtained as endpoint. And coming to the uses of magnesium hydroxide mixture, it is used as antacid, also acts as acid neutralizer, used for the treatment of hyperacidity or hyperchloridria. It also acts as acid base regulator, and it also used as laxative because magnesium salts which are having laxative property, so that it acts as laxative. And its solution which is used as mouthwash, the alkaline mouthwash solution. This is about complete monograph of magnesium hydroxide mixture. And thank you all. I express my sincere thanks to the authors of the following books, that is Indian Pharmacopoeia, Inorganic Chemistry textbook by G.R. Chatwal, Surendranath Pandya and V. Alagarsamy. And finally, I extend my gratitude towards authorities of JN2K Kakinada, AP Andhra Pradesh State Council of Higher Education and State Government of Andhra Pradesh for giving this opportunity in making of e-content videos. Thank you all.